Hello, happy Tuesday, happy New Year. It's 2026 now. What fun. All right, I hope everybody had a great break. Enjoy some time with family or by yourself or whatever your preference was. Uh-oh, looks like I need to do some things. What's all this nonsense over here? All right. Okay, done. That's done. Thank you for that. All right, let's move on now. Let's get started. So we haven't played this in a while, so we're just gonna jump right back into it, right? Okay. Can I not complete that? Okay, well, whatever. Oh, what is this? Anyone ever heard of a PGA 33? Oh, wait. Oh, no, I just checked, so we did do it. Okay. 33X6, a pushy stall vendor. Nearly stuffed these in my pocket. Have some NAF undocumented chips, I suppose. All right, that doesn't sound good. We partnered with a major financial services company to create a cryptocurrency deposit terminal for people concerned about turbulence in the financial system. The terminal reads an account number from a cheap magnetic stripe card, accepts a cash deposit, and sends the information to the bank over the internet. Okay, cool. Let's do it. We've got a card reader. We got cash 20, 50, 100, and we've got network. Well, I am going to have to pause already. Happy New Year. Let's see. Maybe I don't have to pause. I'll just respond here. Okay. All right. What do we got? We got card reader is a non-blocking X-bus input connected to a magnetic card reader. Cash 20, 50, and 100 are simple inputs connected to denominations. It accepts and detects 20, 50, 100 yuan bills. Network is an X-bus output connected to a network interface. The user initializes a transaction by inserting their account card, indicated by an 8-digit data packet from the card reader. The user then inserts money as indicated by the cash signals. The user finalizes a transaction by ejecting their account card, indicated by a value of -1 from the card reader. When a transaction is finished, the 8-digit account number and the total amount of the deposit should be transmitted over the network. Seems pretty straightforward. So we need an 8-digit account number. 678, yep. So we get value, we read 8-digit account number. And at the same time that we can read the account number, we can read money inputs, and then the -1 terminates, and we write everything out to the network, which writing it out can be done at the same time that we read it in. Interesting. So we write that all out. Actually, I think that's all. I mean, that is per frame, right? 1, 2, 3, 4, 5. Yeah, we can't just read that all in. So while we're writing that one out, we have to read that in, which means that we can't necessarily. I mean, we can, but we maybe not. Okay, we're gonna use some memory here. And we need, let's put this one here so we can tell what we got here. It doesn't look like values come in at the same time. So we can just simply see what gets added to it. but that can only be, we need to read the number into it, and then we need to read values into it. So I guess we could technically use 2 storages. Feels like too much. Probably don't need all that. We do need this though. Yeah. So this can add up a total. So we can do SLX X1. Well, now wait a minute, because that's gonna have to. Well, we can't, because we can't sleep on X1. Yeah, we're just gonna write to it. Yeah, the problem is that, see, this is gonna modify it as it gets read. We can start reading here. Some of them do line up quite close. But theoretically, should be fine as long as they stay ahead of each other. But we definitely can't write to it at the same time that we're reading from it. We've got an add up, so let's take a quick intro break here. Okay, here we go. So, yeah. I'm hesitant to use 2, but we're going to be reading and writing, so I really do kind of need, like, it really does kind of need to be its own thing. And then as far as to like where it goes, I guess we'll use the accumulator, and we'll flip between 2 different addresses for it. So we'll say SLX X1. So when we get a value on X1, we're going to copy. I can use dat. So we're gonna copy I'm forgetting, what is it? Move X1 into the accumulator. Then we need to basically test equal accumulator 100. We're gonna move. So I don't know what 100 would be. I always forget which ones these are. If I pull you back, 0, 1, 2. So I think this would be 100. So 100, we're gonna move 100 into accumulator. Test equal accumulator 10. Ooh, that's bad. And then we'll jump right. Test equal accumulator 10. We're gonna move 10, 50 into the accumulator. Jump right. And then we're gonna move 20 into the accumulator. And then we've got right here. So right is going to move dat over X3. And we're going to add, we're going to add X2 and accumulator. We're going to add X2. We're going to move dat X3. We're going to move the accumulator to come on now to X2. Yeah, that was more annoying than I thought it would be. So like 100 is unchanged really. So if we do it a different way, let's say if it's equal to 1, we move 20. and we jump right. But 20 is not going to be, I don't think we need to jump right, because that'll save room. Then we can test if it's equal to 10, which it will be. We can move 50 in there. And then we just do that. Well, we don't actually do anything, because then it'll be 100. It would be 100. Hopefully. So then I don't even need right? Move that in there. But then I need a signal on x0. How can I sleep on x1 or x0? I guess I need to read move x0 to accumulator. If the accumulator is -1, jump swap, or next, I guess. Move x1 to accumulator. And then I can do that. And next is going to do not. Next is going to do not. And then sleep. We'll sleep for 1. Because I actually need to sleep. Yeah, that doesn't work. So it's like, if I control that one, I guess, like, but then I've got to read from it multiple times. That gets rid of all of that, and I can just sleep on x1. That'll get that done. But then instead of moving that to x3, we move 0 to x3. Then we move x3 to dat, x2 to dat. We move dat to x3. We add x2. We move dat to x3. So what I'm trying to do is basically add up. So let's see if this works. So we get a signal. Move accumulator to x2. What? Why is that stuck? Yeah, why? I mean, why would it need to sleep? Oh, that tells us, let's put a 1 there. Yeah. So it's going to read a 1. And for some reason it will not write a value into it. And then then it's supposed to sleep. I really don't understand what's going on here. If it was 10, if I move 10, would it work? Is it because I'm trying to move 0? What? Is this? I think that's the ROM, right? And this one's unwritable. Whoop. Okay, so I think this one's the ROM. That one's not writable, which was probably that problem. So if I do this, we'll just move, because we're going to start at 0. So we're going to move 1 into x2. And then that tells me to write my values to 1, right? Okay. Now, if we do accumulate and we step through here, woo. So we add, why did we add 0? What the heck? Huh? Yeah. Okay. So like move x1 into accumulator, just like. Okay, so I guess that just needs to be a sleep one. So I don't need that. Okay, so we're getting. How did we get that? Okay, come on. Here we go. All right, and there we go. 50's lit up. That didn't change that to a 1. I did read in a 10. So that moves 0 over there. That moves 50 in there. Yeah. And then I get to 270. And 270 is written in there. Okay, cool. So let's swap out that ROM unit for this RAM unit, because now I need to read in the number. Now I need to read in the number. I don't know why I deleted that. I could have used it. This one. Oh. That works. Okay, so now I need some programming module to read in the number. So here we get -999, so we're gonna move, we're gonna sleep. Why is sleep at the top? We don't need to sleep at the top, we sleep at the bottom. Okay, so move x0 into the accumulator. Test is equal accumulator. Then we're gonna jump sleep. Sleep is gonna sleep for 1. Okay, so we got sleeping out of the way. We are not, like, we're actually reading a number now. So then I guess we need to test equal accumulator -1, because that'll be done. So then we need to jump done. So done can go there. And if it's not, then we're reading 8 digits. So we're going to move we're going to move 0 move 0 into dat and our loop. Okay, so we're gonna move accumulator to move dat to x3, that's our address. Move the accumulator to x2, that's our data. I lost, I'm not paying attention to chat. All right, cool. So we got our data moved over. Then we need to read the next value, which is going to be move x0 to accumulator. Actually, I don't need to do that. What if I move that into dat? Because I don't need to add anything to it. I don't need to add anything to it. But what I do need to do is here, I need to move 0 into accumulator. And then we're going to move the accumulator to x3 because that's what we're going to write. And then we're going to write the number in dat there. We're going to move x0 to dat. And we're going to sub 1. We're going to subtract 1. And we're going to test equal or test less than, if accumulator is less than 8, we're going to jump RL. Done, unfortunately. For done, we just need to move 1 over x1. So we need to escape a signal over here, where this one is going to have to read. It's going to have to read from multiple things. Actually, we could do U. No, it is going to have to be the big ones. So I can go backwards, actually. Like that. That's not working quite like I need it to. So let's just move you out. Maybe that's what I need. Okay. And then address goes there. And then you write to the pin. Oh, it's an X. Oh, it's an X bus. Okay, so I can use my little guy. Perfect, because you're writing the total out. You're basically at the end of the process. So you write that. Okay, and then up here, you are handling the bigger stuff. I can do P to P. Like, that's fine. And then that needs to signal to that to write, and that needs to write the numbers. So a done here is gonna tell this to, we can't sleep on that. But my other pins are loaded. So that's just how it's gonna have to be, ain't it? Yep. I don't like that it has to. Yeah, it'd be great if we could just wake up. So why don't I do just that? A wake up or a waker upper. X to here, and then you can signal there, and we can move this up. Move this over. Move this over, yeah, so we can do that. That way you can come up and go X to X, and then X3 can go there, and I can have that. Okay, this is way too complicated than it needs to be, but yeah, all right, so. All right, X0. So when X0 gets a signal that we're done, we need to move X0 to the accumulator. This doesn't really matter what it is, it's just moving. Then we need to move 1 over X2. We need to move 1 over X3. We need to sleep on X3, then move 2 over X2. And then we're done. So that's basically saying flip the script on it. So we're going to move sleep on X3, move X3 to the accumulator, test equal accumulator. If it's equal to 1, we're going to move 0 to X1. We're going to move X2 to accumulator. We're going to not. Okay. Shit. Yeah, that code already too much. Those little ones, man, they can barely do anything. I tell you what. They can barely do anything. Now I have a problem here. Plugging all this together. Yep, I'm a little loaded. I could reduce this one. We could move this back a hair, and we could go up that way. And then this can come here. That just needs to go up like that. And then you can go up. And then we can bring that back. Which means we can now bring this one back some. I could condense it even more if I needed to. But is that really going to matter? Probably not. So I could have this one signal. But then this one can't signal there. Oh, this is frustrating. I just want them to sleep. Okay, maybe I'm just complicating the code too much. Maybe I'm overthinking the code. So we're going to receive 2 pushes. Doesn't really matter what they are. So we've got to move X3 to the accumulator. And then the first time we just move 0 to X1. And then we move X2 to accumulator. We do a not on it. We move, whoop. No, X3 is right. Then we do a not. Then we need to move 0 to X1, move accumulator to X0. Then we need to sleep X3, and then we need to move them out. Yep, we need to move it out. That's what I'm saying. Like I just need a hair more lines of code. I did look up a solution to the last one that we did, and like the optimal solution was like embarrassingly like 1 line, like 1 unit. And it's just like I don't get it. How do you do that? Okay. So like that's a minimum there. Let's just try and get this one written. So we're sleeping on X3, right? Because it's got to do multiple things. It's got to do multiple things. I can't multiplex a signal. I mean, I could with that. multiple things could read it. And that could tell them to do work. Which is kind of what your job is supposed to have been. So, what if I didn't have you? The design, like the programming part, if this is just programming, this game would be pretty simple. But it's the fact that it's more than just programming. So, yeah, I really just need... I mean, I don't really like the fact that I have to pull on these things. What are these? These are logic units. What do they do? I should look those up, right? Let's pull that up. Let's dig into some logic units. Because it's basically a state machine. Maybe that's overthinking, right? Because like one, we're reading in numbers, we're pushing them. Bing, 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 bing. And then as soon as we get a -1, I mean, look at, like, there's a lot of code, right? I don't have 3 pens on a single unit. I can't link them up. I mean, I suppose I could link them up, but it just doesn't feel right. Okay, where are we at? That's not logic units. That's not logic units. Okay, here we go. LC70G04 is a inverter, 1 in, 1 out inverter, 1 in, 1 out inverter, 2 in, 1 out AND gate, 2 in, 1 out OR gate, and 86 is an XOR gate. And an inverter is not what I need. I don't need an inverter. It's like updating these values is a pain because you have to write the address, read the data, update the data, write the address, write the data. It's just so frustrating. Is there more advice on how to handle that? Random access memory. With its convenient auto-incrementing feature, you won't have to waste precious registers keeping track of memory addresses. I beg to differ. 2 independent auto-incrementing memory pointers. The following example circuit. What is this thing right here? What is that? That is very complicated. Ooh, I turn those on. These like feed into this. And that one feeds into this. And these all feed into that. That's an AND? I have to look that up. Let's see. All memory cells initialized to a value of 0. All memory pointers initialized to point at the first memory cell address. Memory pointers can be read and written over X bus with the A0 and A1 address pins. Memory values referenced by pointers can be read and written to. I wonder, out of curiosity, if I were to write 14, what does that do? Yeah, let's get rid of that. I don't. We'll just plug you in there. Sure. And we'll get rid of that. Pin is not connected. P1. Okay, so we're doing P0. Okay. Advance. Whoops. Over X3. Yeah. But I can't tell it to go back one, right? Right? Like if I write A1 and then I move -1 to X3, what happens? It goes to the end. Great. Great. It's like I'm just trying to keep track of the current total. And I'm like, sure, I could do it as like a running value. But I can't easily go backwards. The following example circuit reads in 3 value packets from one input and writes them. Move 0 to X3. And then move 0, X0. You know what? That does mean that up here, I did. So move 8 into the accumulator. Move X2 is data. X3 is address. So move 8 in the accumulator and move 0 to X3. So we're going to start at 0. Then we move data to X2. So we write it to the data. We subtract 1. If we're greater than 0, then we continue. Yeah. I only have to write the address once, so I don't have to write it every loop iteration. But with this one, I don't need memory, I suppose. Because it's we're never receiving. So really, I just need to output that value. So when we get to this point here, we simply move the accumulator over X3. Then I could probably get away with an X, a little X here, that just says when I receive yeah, so that's when I need 2 registers. So move X1 into dat. I can't test if I can read from X1. I don't need either of those. Move accumulator to P1. Yeah, SLX can't sleep on multiple registers. That would be too useful. And I can't test if I can read from a register. Add, subtract, not, digit set. Sleep until data is available to be read on the XBus pin specified by the operand. Okay. So what we can do is we can hijack it. We're going to have one XBus. And that's going to say, we're just going to sleep on it. We're going to sleep on X3. We're going to move X3 into DAT. We're going to test if DAT is -1. Jump out. Otherwise, we're going to add DAT to our accumulator. And we're going to jump back up to our start line. And jump start. And then out is going to move the accumulator to move accumulator X3, move 0 to the accumulator, and boom. All right. Wire up X3, and we are golden. Okay, so we've got reading values in. Why aren't you sleeping? Move the accumulator to X3. And sleep on X1. If I get my X numbers correct here, okay, we should be totaling up our values. Okay, so we do need... well, actually, I do think I need some space here, because this has to go through until that we're done. Yeah, it's got to go through here and say I'm done. What does that look like? Okay. And then over here, you need to go to X. Okay. Well, schnapps. No, I need that to go there. I do need that to go there. But we could go through it. So roundabout. So roundabout. And then that one can go there. They don't connect. X1 needs to be connected there. we're gonna P1. Now how do I ask for it? Yeah, how do I ask for it? Shit. Yeah, that's how we do it. We just wire it up that way. So when it gets an X1, it moves out on X3. Yeah. All right, X3. Here we go. Okay. I think I'm thinking too much in my head. It's going to take some time to get back into... It's kind of like talking mentality for streaming here. How's our performance looking? Really good. Really good. Stream performance is good today. Okay, so here we are. This will get a -1. This will send it here. We already read -1. So once we get a -1, we're going to jump to our output where we write the current total we have over X3. This is now going to sleep on X2 because as soon as we get a value, we're going to move X2 to dat. We're going to move 0 to, what's the address? X1, that's our address field. And we're going to move 8 into the accumulator. And then we're going to do our read loop. We are going to move X0 to X3. We're going to sub1. We're going to test while we're greater than. While the accumulator is greater than 0, we'll jump back to RL. Otherwise, we move dat to X3. And we are done. Right, so that should theoretically work. We write our count. Holy Moses, what the heck is that? Okay, we need to work on our reading. So we got -999. All right. Here we go. It is not equal to -999. Move 8 into the accumulator. We move 0 to X3. And then we move that. Okay. We move 0. Okay. I think what we need is we need a sleep in here. Yep, we need to sleep in there. Yeah, because I'm just reading 0 over and over again. Okay, I'm still reading zeros because we're not moving dat. We're not moving dat. Okay. Move X0 to dat. Is it 9999? Yes, we jump there. Is it -1? We're done. Okay, let's rewrite this node. All right, so what do we know? We know that we're going to move X0 to dat. If it is -1 for sure, then we jump done. Otherwise, so we need done. right? We have to have that. Otherwise, if it's negative 999, then we sleep. So sleep, we just sleep for 1, right? Next, we will move that to x2. Yeah, we just write it to x2. And then we jump sleep. Yeah, we do that. Because when we hit done, we're going to move negative 1 over x1, and we're going to move 0 to x3. So we're going to reset our position. Okay. So now we've got 0, 0. Okay, we're still getting zeros every time. Oh, it's 3 zeros. That would explain it. We get a 7. We should write 7, okay. And then we write 4. And then we write 3, 9. And then we just sleep. That just works. We've added up 270. We hit negative 1. That goes 270. Up there. And then that writes a 0 in. And that starts reading off the address code. We've written, then we write the total. We're good. Okay. Yeah, okay, cool. I think that's gonna work out. So let's test. What was I doing? Okay, so here, what I want to do is if accumulator is greater than 0. If it is, we move that to x3. If it's not greater than 0, then there's no reason to wake this up. Yeah, so now that thing can sleep more. It only needs to be woken up when there's something on it. Okay. We got our 270. Boom. And now it's totaling the next one. Boom. Boom. Okay, let's simulate. Well, that was rough to start with. Okay, so our cost is high. Our lines of code and power usage is average. What do we get? Great. I think we can catch this wave. Yeah, wish my own currency, no politics. Right, I almost forgot. All right, 55% of homes are infected. Is yours? The fortress protection. I hope my home is not infected. Yeah, really hope my home is not infected. That would be great. Let's see, what do we got? I'm working on a smart window that reacts to particulate matter in the air. I need a controller that allows us to close the window. Let's check on. Okay, stream looks good today. Good. Let's open it up. Boom, what do we got? We got a sensor as a simple input connected to an air pollution sensor. Window is a simple output connected to a motor that opens and closes a sliding window. The window should be closed, signal low. When the average sensor reading for the 8 most recent time units, including the current, is greater than or equal to 50. That's like a rolling average. So, like, how would we do that, basically? So this needs to read numbers, and that needs to read output. What do we got? Okay. So sensor comes in, and we're either on or off. So it looks like we need to start on. So let's just wire that one up. We're just going to start on. And we're going to move the accumulator to window to, what is that, P1? I don't know why I called it window. We're going to sleep one. And for now, that's what we're going to do. That's how it's going to be. And so that'll just do its thing. But that needs to close. So we need to do a rolling average of 8. 8, which means we need so I could approach it in a couple of different ways. Let me just look up rolling average here. So I think there's a simple way, maybe moving average. It's a calculation to analyze data points by creating a series of averages of different selections. How would you calculate it? I think you need to maintain choose a window size for each position in the data series. Take the average of the current value and the values that come before it. Slide the window forward by 1 data point. Yeah, so that's great. That starts, yeah. But how do we implement that? That's what I want to know. An cumulative average. A user would like to get the average of all the data up until the current datum. I don't want that. Yeah. Okay, so that's how it goes. Okay, so I guess we're going to need not read only. We're going to need some ROM here. Yay. Because this is going to have to write into there. Boom, 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 boom. Can I read the current address? So if I move 1 into X3 and I move X3 into accumulator, what do I get? Oh. Okay. Okay. So move. That's got to go into P0, right? So move P0 into dat. I guess we'll just move it straight over to X2. Then we're going to move X2. We're going to move X3 into the accumulator. That doesn't tell me. No, that doesn't help. Okay. So this is why, like, that's a lot of zeros. Let's just try it. What I was thinking. All right. So if we just start off really dead simple, right? So we're going to move. Well, we're going to read a new value, right? So we're always going to sleep at the end. So we're going to move value. And so what we're going to do is we're going to sub dat. But that's not. If I go to 14 and I go 15. Actually, I think I can. Okay. So we will use that. Okay. So if we move the value of P0 into X2. Then we move the value of X3 into the accumulator. Or into dat. How do I do 8 times then? I can't swap the accumulator and dat. I don't have like a swap. So that is frustrating. Yes, that is very frustrating. Where are you? What am I looking for? I'm looking for another browser window. That's why I can't find it. Okay, what do we have? So what I'm thinking is, what I need to do is I need to read the current address. Oh. Okay, no. Then I need to move 8 into the accumulator. And no. I need to move X3 into the accumulator. Right? Move X3 into dat. Move it into the accumulator. Because then I'm going to sub 8. Then I'm going to move the accumulator to X3. Then I move 8 into the accumulator. Then we're going to do our loop, our average. But I can't, son of a gun, I can't add it to dat. That's fine. This can just write. That can just write to it. This one can read the average. That's fine. This one can read the average. Okay. So yeah, every unit we're going to have to read the average. So we're going to, that's not going to work because we need to know the current window over there. Maybe we could just pull that off there. As long as we only read from it, it shouldn't be a problem. So if we move x2 into the accumulator, I don't think I can. You know what? Can I fit 8 in here? Move 0 accumulator, right? Then add x2. Add x2. Add x2. Add x2. That's 4. That's 8. Div 8. Okay. So the answer is no. I can't do that. Right. What is it? Oh, please tell me we don't have. Please tell me we have a divide. Please tell me we have a divide. Math, math, math. No. We don't even have a division. We don't even have a division. Son of a gun. Wait. Yeah. I got it. We don't even need that. Oh, I do need to add it up. So I do need to iterate. Subtract. It's like really annoying that I can't. Like I need more data basically, but now I have to implement division. Great. How do I implement division? It's just a series of subtraction. Yeah, so it's the total. How many times will 8 go into it? I'm just gonna look this one up. Let's see how to implement division with and subtraction. Let's see if there's an easier way other than just straight up subtracting. Where you subtract the divisor from the dividend until what remains is less than the divisor. The number of times you subtract gives the quotient. Yeah. See, that all needs more than one register, though. Because, like, I need the accumulator to add up to what I'm doing. Let's see if we can find a trick for rolling average without division. Let's see, rolling average without with minimal space. A rolling average can be calculated using a method that requires minimal space by maintaining only the current average and the count of values. That doesn't make sense. This technique's, yep, space efficient. Using a fixed size buffer, which is what we were going to do. This would be the buffer. We're using RAM again. Okay. Yeah. Yeah, so theoretically, if we read the values in, we got 1, 2, 3, 4, 5, 6, 7, 8, and then we could just sum those. But in order to sum those, we've got to iterate 8 times. In order to iterate 8 times, we need accumulator, or we need to read it 8 times. And then we need to subtract 8. Keep track of the current average and the count of values. When a new value is added, update the average using the formula. Okay, so yeah. Well, I don't think there's a way for me to get out of it without keeping track of all 8 data points. So I need something. I need one place to write the data, one place to sum the data. So what we could do, I suppose, is drop an X out here. So it should be X0 and X1. Yeah, okay. And that's data. So X0 is our data one. So we're going to move. Let's put it on X2. So we're going to move X2 into X1. Yeah. That's going to be our address. Or I guess we're going to move that into accumulator. Sub 8, move accumulator into X1. Then we're going to move 8 into the accumulator. And we're going to move X0 to X3. And we're going to sub 1. And if it's greater than, test greater than accumulator 0, we're going to jump RL. Otherwise, we're going to sleep 1. And then we're going to go back and do it again. Okay. So that's our average coming out. Now I need a place to read that average. Could I move this up here maybe? You go there, okay. And then I can only pull one value straight down. Can a bridge jump over a pin. It can, but that bridges it. And then you can come down the middle, right? Okay. Okay, so we have x0 goes to our address, and x1 will go into our data. Okay. Now we can move you backwards one, and then we'll move this one down here. Yeah. Okay, we've got that in place now. We've got a pin there. We can get x3 over here. So that will get us a total. If I put an X, how far in the corner can I put an X? Right there, so not very far. So move move 8. Can't do it. 8. I think testing's gonna consume it, which means I'd have to write every value twice, and I don't have enough room to do that. So yeah, so that can write all the values, and that can read all the values. And I suppose this may not need all of that. Well, let's just assume we could do it with less. We can pin that one up, goes there. Well, that definitely won't work. I have to do that. That won't work either. Okay. So then you can come down. There we go. So I don't need a bridge in this scenario. Okay. We've got this convoluted mess. This is basically just gonna write. It's just gonna move x p0 to x0. Do I even care about the address? I don't care about the address. Do I? Maybe I do care about that. Because then I can move. Okay. So we move the value in, then we move the address, which is x1, into the accumulator. We sub 8. Then we move the accumulator into x1. Then we move 8 into the accumulator. Then we move data is x0 to p1. Sub 1, test greater than 0, accumulator. I don't have time to sleep. Crap. So if I moved -8 into the accumulator, then I could add x1. That doesn't That doesn't reduce anything. That doesn't reduce anything. Okay, so we're struggling to write. Like, I do need a little bit more code. To read the numbers. But I'm also doing the work in this unit over here. Okay, so let's get our registers right. We do need to do the bridge again. We need a bridge. Bridge comes down to here. X0 goes there. Okay. And then P1 we can write over X1 now, whatever. X3. That's not P3, that is X3. Okay. So where were we? All right, if it's greater than 0, we jump back to RL. Otherwise, we sleep 1. So that's moving over here. So we're going to move 8 into the... All right. So you need to be a big boy to... you can't be a big boy because you need... I think I just need to write it. Just write it out, right? Just add... what is it? X01, X1. Move 0 to the accumulator. Add X1. Or move X1 to the accumulator. Add X1. Add X1. X1. And then we do that 3 more times. X1. And then we move, but then I don't sleep. I wish there was like a way to repeat commands. I think there was like some kind of note. Let's see. If I can type the name correctly. What do we got? Let's see. Just reading some tips and tricks. I'm wondering if there's some way to do additional parts. I don't want a level walkthrough. None of those are what I want. Yeah. Got that. Focus on efficiency. Yep. Let's see. Okay. Mm-hmm. Just trying to find some info on what's going on. So basically, we're at a kind of like an impasse here, where over here or over here doesn't matter. I need to loop 8 times and add into accumulator. But the problem is math like add x0. That only adds to the value in accumulator. So if I had like move 8 into accumulator because I want to loop 8 times, I can't also add like total values in the accumulator. And I can't add them to dat either. So yeah, it's kind of a frustrating puzzle. I'm trying to see if there's some undocumented commands like I know there's this one that lets you do like initializing, so it only runs once. But I think I'm wondering if there's maybe there's something like in Exapunks where it's like REPL this line of code like 8 times or something. But that does expand. We don't have room to expand, so I don't know. So far, some solutions are trying to give me answers. I'm not looking for answers, so I'm ignoring those. Okay. Maybe if I look specifically for a language reference for Shenzhen I. Okay, that's the guide. That's the actual manual. That is a very nicely documented manual. Parts data sheet. Oh, that's very nice. Okay. Supplemental data, contents. Oh, that's really nice. Yeah. That's great, but what do we have here? That's not... There's a reference card. Okay. So I found a website that just basically turns the document into navigatable. So that's really great. That's like an awesome resource. Not really what I was looking for, but that is a place. Okay, here we go. Okay. Yeah, all right. Test instructions. Okay. Yeah. Oh, it was the gen command is what I was thinking of, but that doesn't really do what I would need it to do. Gen P register generates a pulse on the specified pen for the number of time units specified by the first and second operand. Yeah. Oh, this is not helpful. This is not helpful. Yeah, I'm really struggling here. Okay, let's stop looking for solutions because we haven't found anything, and that's not being very useful. Let's get back to it. Okay, so we've got to implement. We've got to implement adding. I guess if we do it the hard way, right? I mean, it's better than not doing it at all, basically. So we are going to. That's 4 and 8. That's 8, and then we move the accumulator to x3, and we sleep for 1. All right, so we've got that done. But now we have to do it again. Actually, no, we don't. We do need to add to dat, though. It feels dumb, but I guess we could technically build that into its own little thing. Oh, this is turning into a lot. Okay, so if that pushes... So if that pushes out like that, is that connected to x2? So if I move 0, x2, are you going to tell me? Yeah, okay, that's not connected. That's connected. Okay. Okay, so we're going to sleep on x1. We're going to move x1 into the accumulator. And this will sleep on x3. This is going to be our adder here. So we're going to move x3 into the accumulator. And we're going to add 1, and we're going to move the accumulator to x3. And that's all it's going to do. That is it. Okay, so we move the x1 into the accumulator, and then we loop. Oh, actually, we need to move 0 into dat. Okay, now we loop. So here we sub 8. We test greater than 0. If accumulator is still greater than 0, if it's not greater than 0, then we jump done. And so we need it done. All right. If it is greater than 0, we won't have jumped, and we will move dat to x2 and move x2 to dat. So that'll increment that. That will increment that. And then we jump loop. That'll figure out what our average is. That'll figure out what our average is. And then when we're done, we will move the accumulator, or we'll move dat to x3, which will determine if it should change the window or not. And then we'll sleep one. Boom. So now we need an x3. That's a P. That is a P. Can I do this? Can I do this here? I can do P0 like that. And then I guess that can come in like that. Ooh, no, that won't work. Can you go backwards? And then you can go that way. And then you could go maybe if we pulled P0 up like that. Or maybe even more up. Let's bridge it. And we'll go that way. Okay. Then you can come into X1. Perfect. Just like that. All right, so we're going to sleep on X1. When we get a value on X1, this is going to move 100 into accumulator because we start with 100. We're going to move... I guess we just need to test greater than 50. Is X1 greater than 50? If it is, we move 100 into the accumulator. I wonder, actually, because I do have to write it out every time. So if we are, I think it's closed if it's high, right? The should be closed signal low. Okay, so open. Yeah, so it starts off open. So we're going to do open. Test greater than 50. X1. If it is, we're going to jump closed. Opened. We're going to jump closed. And then here we're going to move 100 to P0. Jump opened. Sleep one. Okay, I don't have enough for that. So basically, this one's easy, right? Greater than 50, X1. If it's greater than 50, or maybe I should say greater than, right, I know what is the specification. Is greater than or equal to 50. The window should be closed if it's greater than or equal to 50. So I should say if it's less than 50, the accumulator's less than 50, we want to move 100 to P0, otherwise we want to move. And then we want to sleep one. Okay. Let's test it. Why did that write -8? What the heck? Why did that write -8? Move -8 into the accumulator. Add X1. move x1. X1 is data. X0. So move P0 to X1. Okay, and then add X2, X0, and then move the accumulator to X0. And then move X1 to X3. Okay. So first we write the value in. Then we go back and we do 7. And we write 0 out. This part's not sleeping. Oh, because it's testing the accumulator. Son of a gun. Okay, now we wire it all up. Alright, let's solve this so we can figure out what I did wrong. Yeah, alright, so that should open it. We get an average of 4. Okay. I mean, it's hacked as heck, but it works. It works. Fudge. It didn't work. Why didn't it work there? Why didn't it work there? You're not gonna let me see that test run, are you? Alright, well, what test run was that failed? Test run 8. So if I run it, we're good. And if I slow it down, if I advance, if I simulate it up to that point, I should be able to set a breakpoint. Can I set a breakpoint, right? Control click there. Alright, so now we simulate. It should get to that point and stop. Alright, here we are. So where are we at? We read a value of 100 in. We go back. That's 1, 2, 3, 4, 5, 6. It should send 100 twice. Don't send another value. Okay, so that sends 200 over. 200 divided by 8 is... What is 200 divided by 8? A lot. Okay. Is it going to advance time? Is that why? Because it's taking too long. We send over 24. That's good. So then that runs so slow to step through here. Okay, now we've got to sit through all that again. Now this one is the one that I want to see. Yep. So what are we calculating our average to be? $400 divided by 8. Okay, well that was way too fast. Let's set our control point closer so we don't have to click through so much. Like right there, maybe. Okay. Okay, now I don't have to click through so much, but we got 400. I gotta click it. That's the annoying part. Profiler. Is that showing what lines are doing the most? Yeah. So we've got a lot going on here. So we could do it a little bit faster if we subtract. Hello, stop that. It went through. Okay, if we subtract 16 and then we add 2 to it. We can that's gonna, if I add 8 and then test it, then I gotta copy that. Add 8, test. So add 8, test, copy that. I'm out of commands, so we can't. Just do it that way. Oh yeah, we want to jump ahead. Okay, stab. I wish tab does that. Step doesn't seem to be tied to a control command. So can I like jump ahead? Oh, I can click to add breakpoints there too. Cool. So I can just do that, right? So we got 49. And what is the actual average? 400. 400 divided by 8 is 50. So we are off by 1. Oh, wait. Test if it's greater than -1. There we go. That should fix it. All right. Now if we simulate through to 8 and we put our breakpoint back there, then we're at 50 and we're good. We're golden. That is our golden ticket right there. Okay. We were off by 1. The dreaded programming error. If you're not really a programmer until you're off by 1. Okay, so that was the worst of all. Okay, so let's find out how to do this in a not stupid way. Let us return to our email so that we can... open this concept up, and we're going to figure out what the optimal solution is. So Shenzhen, this is how we learn. We solve it on our own, and then we figure out what the better one is. Okay, so given the MCs, but there's a little shortcut that I can take here since it's always an average of the past 8. Sum of readings divided by 8. Sum divided by 8. Times 8 is greater than or equal to 50 times 8. Is the sum greater than 400? That's smart. That's smart. That's very smart. Wow, this is a really pretty design in this picture here. Yeah, actually using Math Brain. Okay, so they used one of these and one of these, and we've got a lot of wires. We got this wire going here. We got this one going here. We got this one going here. I think they made it pretty on purpose. That's what I'm thinking. And then these are bridged like that to go here and here. And then this goes here. It's like a spiral. It's like bing, 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 bing. That's probably intentional. All right, so code is we move P0 into X0. And X0 is our data. So that's basically what we did. We move X1 into the accumulator. That reads the current address of where we're at. We sub 8. That's so far so good. Move the accumulator into X3. Yep, that's where we're at. And then we've got our loop. And then they do add X2. Test equal X3, X1. Oh, because we're reading from both sides. Yeah, X2 is reading that data. Test equal X3, X1, and jump loop. Otherwise, test greater than 399. We move 0 to P1, or we move 100 to P1, and we sleep for 1. And that is wrong. What happened there? Did I write something wrong? Test greater than accumulator 399. Move 0 to P1. Interesting. That's interesting. What happened there? What do you think happened there? All right, so okay, and then we step through. We just accumulate. That is greater than, so it writes a 0 out. Then we write another 0 in. Zero, zero, zero. I must be missing something. Move X2 into the accumulator. Right before the loop, move X2 into the accumulator. Okay. There we go. We don't need that anymore. Yeah. And that gets us pretty low production cost, power usage. That's not the most optimal, but as you can see, it's significantly better than my other solution. Yeah, like 31k power, 23 cost, 39 lines. Yeah, so we need to be a little more creative by first off figuring out the maths of it all. Okay, that's 2 minutes till, so we'll stop early tonight. Otherwise, we'll hit another ad. And that was enough brain busting for the day. That one really got me. I did find that extremely cool resource that lets me browse the guide better, so that's cool. But that'll be it, yeah. So cheers, everyone. I hope you had a good time back. I'll see everybody on Thursday.